now we're moving over to a presentation from BreanneBoland. It's called How to Do Chrome Extension Code Reviews. Chrome extensions can access a lot of users' data, cookies and tokens, downloads, and anything you view in Chrome, just to name a few. This makes fertile ground for bug bounties, particularly as the Chrome API scopes can be so broad that developers sometimes open the door to permissions they don't intend to grant.
Hello, LevelUp and Bug Crowd folks. Happy late evening. For the next 15 odd minutes, I'm going to talk about a lesser known area of bug bounty hunting, Chrome extensions. And I'll explain the steps I take at my job to do code reviews and assess risks in them. I used to be an SRE, and when I was doing that job, I developed an interest in the kind of threats that are hidden in areas of code that people think of less. I now do application security engineering at Salesforce. I've been delighted in the course of my current job to get a sense of where the vulnerabilities are in Chrome extensions, as reviewing them is a need that comes up pretty often. Reviewing Chrome extensions is part of a wider range of work that my team does. We do vendor security reviews, and extensions come up as part of that, as companies often make extensions to work with their products. Like their web interface counterparts, Chrome extensions can also have lots of weird little corners that can hide vulnerabilities. Our criteria are a little bit different than an average individual should be, but it's given me some insight into how Chrome extensions can go a little haywire. The good news is that what's bad for the end user is good for the bug bounty hunter. So why focus on code review for extensions? 1, because you can. And 2, some companies do consider Chrome extensions to be within the scope of their existing bug bounty programs. And beyond that, the Chrome Web Store has its own program for reporting vulnerabilities. Why else do code review? Because of Chrome's incredible market share. Extensions open up a really interesting attack surface. According to my extremely cursory research on Wikipedia, Chrome has approximately 63% of the usage share of all browsers. So it's kind of everywhere, and people who use Chrome love extensions. And why wouldn't they? They're so useful. What could possibly go wrong? Once they're installed, they're just part of the browser, so they're literally embedded in the client, which can let them sidestep some of the safeguards an unaltered browser might offer via things like content security policy and CORS protections. Beyond that, people often have alert fatigue, and they don't think much of a warning like, this extension can read and change all of the data on every web page that you visit. It should be alarming, but that warning applies for so many extensions that it becomes easy for people to ignore. Why else do code review? Because the code is written by humans. Now, sometimes existing Chrome extensions get bought or otherwise compromised, and fine, morally upstanding code gets replaced with malware. But even when there isn't a bad actor on the scene, you might find this hard to believe, sometimes developers get a little sloppy. I wouldn't call this their fault here, not entirely, but with broad scopes and limited time, some messy things can end up in extensions. And finally, why code review? Because it's code. And Chrome extensions update themselves automatically on a timetable determined by the browser. For context, even the browser itself generally doesn't get automatically updated. So you have third-party code nestled right in where the business happens, and that third-party code can change with no warning at an undetermined cadence. Wow. Furthermore, that third-party code has to make use of Google's sometimes very broad Chrome API scopes, but we'll get into that in a few minutes. Before I sound too blamey, I must say, Google is trying. They are trying. But permissions and scopes, as I think we all probably know, are one of the most weirdly tricky parts of building a system. Google still has a lot to do, but they're working on it. For instance, last year Google made some moves to bolster user security by making Google scopes around Gmail and G Drive more granular, while also requiring developers using these scopes to use the smallest access to information possible. This is useful. It's not a panacea. I would also argue they're still not extremely granular when it comes to the Chrome API and how broad some of the permission scopes are. At least not yet. And because of this, there's still lots of interesting stuff to find, which is where I hope you come in. Chrome extensions aren't the Wild West they once were, but there's still plenty of opportunity to find vulnerabilities. I'll start with the short version of how I do code review, and then we'll dive in deeper into specifics. I start out by building a story about the extension I'm reviewing. What does this extension say that it wants to do? But what does it actually do, and is that answer different than the first one? What permissions does it need to accomplish its stated mission? And do the permissions or code make anything possible outside of that extension's stated mission? Reviewing extensions generally takes 3 steps for me. I'll walk through them from the most high level to the most detailed. First, I look it up on CR Excavator. This is a tool I use for the high-level view of an extension. It gives a score that's based on 4 metrics, the most relevant of which to us are content security policy and permissions. The other 2 are whether it depends on externally hosted JavaScript libraries and what the extension's web store score is. And the question of content security policy is a good one to pursue too, as an extension's CSP can override those set by the URL the user is visiting. I use this site to get the extension's aggregated score and see where CR Excavator judges the risk to be as an early indicator. You can peruse the code through CR Excavator's site, it's one of the services it offers, or you can use an extension like CRX Extractor/Downloader to get it locally, which is what I tend to do. After that, I read the manifest.json file. This is where I spend a lot of my time, because it tells me a lot about what's possible. These files can get long and intricate. There are 56 different top-level fields that can be included. However, most of the extensions I see don't use a ton of those. And actually only 3 are required, and only 4 are marked in the docs as recommended. That excludes content scripts though, so pretty much all extensions have to go a bit beyond the minimum in order to have an extension that actually does something. And I'll tell you, if you're looking to dive deep into the weird corners of Chrome extensions, and I hope you are, maybe by the end of this, I'd read up on those different fields and find your own niche. I'm in the process of doing exactly that. There's so many of them that your interest is likely to wane before you even exhaust the list. So in manifest.json, I look most closely at the permissions, both the Chrome API permissions included and the URLs that are cited. Permissions are the sketch of what can happen. The code, of course, determines what will happen with them. Because of that, I spend a fair amount of time on those permitted Chrome API operations. The permissions don't encompass all the possible risk in an extension, but they cover a lot. In the next step, I search the code for where they're invoked, to see what methods are being used and what's happening after that. You can set general API permissions, but you can also set permissions for the specific content scripts in this file. Just JavaScript by JavaScript file, you can be really specific about what's allowed to happen in each one. From there, I read through the different JavaScript files being used and what they're going to be allowed to do. Now, because of the nature of my job, I spend more time on manifest.json at work, because we watch for overreach and it's most concisely shown in that file. If you're seeking bounties, manifest.json is more likely to be a hint at what will lie in the rest of the JavaScript, which is where you'll find what you're actually looking for. Finally, of course, I read the code. I'm looking for weird uses of permissions, and their methods, like chrome.identity and chrome.cookies are both fun, any connections to third-party servers, and anything else that seems overly ambitious with what I know about what the extension is allegedly trying to do. Some extensions have a fairly simple single JavaScript file. Others can have files upon files upon files in a complex nest of directories. The official size limit for a CRX file, which is the zip formatted file format for a Chrome extension, is 2 gigabytes, and that is a lot of room for function and also just utter mayhem. So here's what I'm looking for across all of the extension code. I want to know whether it's sending the user's data to God knows where. What I really want to see is innocuous and clearly described changes to the appearance and contents of the DOM. I really prefer not to see data being collected or sent. If I do see data being collected or sent, I have found the new focus of my time for the remaining time in my testing on this extension. There are legitimate reasons to do this, of course, but they need to be safely done and very well justified. I am looking to see whether it's storing stuff unsafely in your browser. What I don't want to see is plain text secrets stored in the browser. This in itself is not the biggest risk, but it can be a tell that something else is going on that is either messy or otherwise maybe not as well thought out as I'd like. I'm also looking to see if there are wide open scopes that let the extension snoop on everything that you're doing. And then worst of all, if it's snooping on everything that you're doing and then sending that information to God knows where. So what should you do about this? Or what should you know? Companies' official Chrome extensions can create weird and surprising vulnerabilities for their customers. Think about the permissions involved in an extension that alters text typed into a field. It can read what you type, it can store it, and send it across the internet to be judged by an algorithm, maybe with the goal of furnishing, say, spelling corrections, which will be read as nearly instant by you. We type a lot of sensitive things into text fields. passwords, credit card numbers, questions to our insurance companies, emails to people we love, and I personally don't trust an extension to have fine enough control to not at least process the text written in fields other than the ones it's supposed to be targeting. And let me tell you, even well-funded companies have too loose permissions and other weird stuff happening in their extensions. It's the nature of this very particular medium. There's a new opportunity with every extension update, and some of the extensions are updated pretty often. Let's look at a few of these permissions now that I've spent some time broadly demonizing them. Permissions for an extension come in two forms: URLs, either specific ones or patterns, and Chrome API permissions. These cover all kinds of possible interactions: alerts, accessing and updating browser storage, accessing bookmarks and tabs, among many others. There's a safe use for every permission, but there are also permissions that, if included, are a great place to start when reviewing an extension to make sure it's safe for the user. Here are a few. First, let's look at URLs and their patterns. For an extension to access a site, its URL must either be specified or match a pattern. Conveniently for devs, there are patterns that make matching very easy. Conveniently for bug bounty hunters, that means that a lot of devs leave the doors much more open than is necessary, maybe because they're trying to future-proof their extension, or less commonly because it's something that has any business doing something on any site you visit. In manifest.json, you can include and exclude URLs based on these patterns, but including is much more common. So if I see either of the patterns that you're looking at here, I start looking at things very carefully. These permissions give an extension carte blanche to work on basically any website you visit. Your email, your bank, your employer's web portal when everyone's working at home. This is hard to justify, although a few extensions can. Google themselves declares wide open wildcard patterns to be the highest risk type of permission, with this all URLs permission the next most. So these can be at the top level permissions in an extension, or they can match a particular content script. All of this is laid out in manifest.json. So what does that mean? Cross-origin requests with none of the usual barriers your browser would present, all because of the extension's interference. It also allows JavaScript injection on any site the user visits. Fun! One reason people do this is to avoid CORS errors. However, I promise this can be done effectively and more securely. It just requires a little more work to narrow down exactly what URL or pattern needs to be put into place. Beware asterisks, especially beware asterisks with only a host or no host at all. On the plus side, it opens up a lot of interesting territory for the bug bounty hunter. Silver lining, I guess. Next, let's look at the web request API permission. This lets the extension change, remove, and add HTTP headers. It also lets it add listeners and change behavior upon receiving the first byte of a response, at the initiation of a redirect, when a request is completed, and anywhere else in the lifecycle of a web request. This can, of course, be used totally legitimately. However, it's also been used to intercept and forward user traffic, so if it shows up in the manifest, it's worth looking at every one of its methods that's used in the code. It also has to be paired with an appropriate host permission to be able to do anything, which is the case with any permission. So web request is likely to be in flux in the future, but for now it's still here, and it's still weird enough that even the EFF has weighed in on its present and future. Finally, let's look at the cookies API. This permission offers methods around getting, setting, and removing cookies. This can result in a lot of interesting possibilities, particularly when paired with collecting data and sending it somewhere. Fortunately, the solution for this is the same as cross-site scripting. Set that HTTP only flag on that cookie so it isn't accessible via the JavaScript of content script. However, if people faithfully set that flag, my job might not need to exist. And yet I remain employed. So it's worth mentioning as it still comes up regularly. There are other horrors in the permissions gallery. The file that you're looking at here is worth a read because it goes into corners I typically don't get into in my own Chrome extension reviews, but they might be relevant to your own work. Removing the escape key's ability to exit full screen, spying on the user with their own camera or microphone, nightmares, but they're not impossible ones. But let's look a little more at the code that you might find in an extension. The things I watch for are, again, shaped by the particular concerns of my team at my very large company. But my primary concerns are about accessing, storing, and sending information. I watch for any input text being saved or otherwise manipulated to start. I find out what's being collected, if the collection and handling of that information supports the story I've put together about the extension through my research, and if not, where do the two diverge? After that, I check for HTTP requests. If I find them, I look at what they're doing. What's being stored and sent? How is it being sent, and where is it going? Is it something the user of the extension will have opted into via an account, or is this being done more quietly? Most extensions also have an HTML component, often for creating a customized menu for the extension. If you see a file called popup.html, it's likely this. These are subject to the same vulnerabilities as any web page, so it's worth testing for common vulnerabilities like cross-site scripting. The same is true for other tells, like the use of inner HTML. Basically, if it's something you'd try on a regular web page, it's worth trying on the menus and other pop-ups that are part of an extension. So, I want to conclude with advice to you bounty hunters. We need you, generally, of course, and I think the world of extensions in particular would benefit from your attention. Beyond what the permissions and code can yield the first time you look at an extension, I think the particular opportunity of how extensions are updated offers a lot of possibilities. The releases for extensions, unlike those for, say, a company's website, are numbered and they're publicly available. You know if something's changed, enough that Chrome has a page for it that you can just keep up on. Now, right now, this isn't the most popular category of bug bounties, but they do exist. Maybe I should be optimistic and say it isn't the most popular category yet. If you're looking for them, check by company. And if the company itself doesn't include extensions in their bug bounty program, Google Play has its own extension bounty program that you can check out. And because I interact with them so much, I also need to offer a little advice to extension developers. Your job is not easy, but here's what I ask. Please make a priority of using the minimum viable number of permissions, including URLs, especially URLs. If your extension doesn't need to alter the entire internet as accessed through any given person's Chrome usage, don't include it. Your users will appreciate it. And, of course, handle personal information like plutonium. And also, please don't sell your moderately popular extension to entities that want to exploit people. Please. Thank you very much.